here of energy and phase change. So this problem goes, how much energy is needed to change 50 grams of ice at negative 17 degrees Celsius to steam at 115 degrees Celsius. So as I said, this is an example of a phase change from ice to steam, meaning we're going to change a solid ice into a steam or vapor from negative 17 degrees Celsius to 115 degrees Celsius of steam. So all of these are from water, from ice and steam. To demonstrate these changes of phase, we're going to plot the change of the water from ice to steam with its temperature in degrees Celsius against the time from which it is changing. So we're going to start, in our given is negative 17 degrees Celsius. So we'll start from solid ice. We're going to add heat in order to bring this solid ice into 0 degrees Celsius. So we're going to introduce heat in order to change the solid ice from 17 degrees Celsius into 0 degrees Celsius, and we will call this the phase 1. And for this, we're going to use the formula of Q equals to mass times specific heat of ice times the change in temperature. So at this time, this solid ice is still not liquefied. So in the second change of phase, we will going to undergo the process of melting of solid ice into liquid without the change of temperature. For this process, we're going to introduce the latent heat of fusion. So if you notice, this is a straight line with the same temperature, no change of temperature at 0 degrees Celsius. So this latent heat of fusion is the energy that we require to change this state without the change of temperature. So we call this the latent heat of fusion, which we're going to use in our formula of Q, or the energy equals to mass times the latent heat of fusion. So the latent heat of fusion is equivalent to 80 calories per gram. So this is the heat required during this process. So we're gonna call this the phase 2. And the next process is we're going to add heat. So let's say this is the 100 degrees Celsius, which we're going to add heat until its boiling point. And we're going to use the formula of energy, or Q equals to the mass times the specific heat times the change in temperature. And for all the process, we're going to use the mass of 50 grams in our given. And by the way, in our phase number 1, we're going to use the specific heat of ice for this process. And for this process, we're going to use the specific heat of water. And we're going to call this phase number 3. We're going to undergo another process. From the boiling point of water, we will change it into steam or vapor with the same temperature, so it is also a straight path without the change of temperature. This process we call the vaporization. So again, we have to introduce what we call the latent heat of vaporization. So in this process, we're going to change the liquid into steam. So this latent heat of vaporization, or we'll call this the LHV, is 540 calories per gram, which we will use in our formula Q equals to mass times the LHV. And we'll call this phase number 4. So at this time, we're going to add heat. So in our problem, we'll have to steam up to 115 degrees Celsius. So we will add heat until it reaches the 115 degrees Celsius. At this time, we're going to use the specific heat of steam, which is equivalent to 0.48 calories per gram degree Celsius. And also we're using the formula of Q equals to mass times specific heat of steam times change in temperature. So these are the phase change from solid ice to steam. And on our next videos, we're going to calculate the energy required for each phases and for the total energy required for the phase change of solid ice into steam.